Hey, this is day 3 of gas laws. Today we're going to work with the ideal gas law. So I'm going to put the formula right here so that we have it handy. The formula is PV, pressure times volume, equals nRT. N is moles, R is the ideal gas law constant, T is temperature in Kelvin. So that we have the R value here, R is equal to 0.0821 liters times atmospheres per Kelvin mole. Yeah, long unit. So in order for this formula and this constant to be used, pressure has to be in liters. So that's going to have to be in liters. Volume is in liters. Forget I said that. Volume is in liters. Pressure is in atmospheres. Sorry about that. N is just moles. R is this wacky unit, and T is in Kelvin. Okay, so we'll need to make sure that all those units are in those, or all the variables are in the proper units. So number 5, how many moles, so I'm looking for moles, how many moles of nitrogen gas are contained in 2.5 liter, in a 2.5 liter sample at STP? Well, we've got some information here. I've got my volume, and it's in liters, so there we go. I know I need moles, so that's my N. R, 0.0821. So I also need a pressure and I need a volume. Not volume, I need a pressure and a temperature. My fault, temperature. So that STP kind of helps us because remember that pressure, standard temperature and pressure, the pressure is 1 atmosphere at standard pressure. Standard temperature is 273 Kelvin. Okay, so even though we don't have a lot of numbers in this problem, we know a lot of things, okay, because it's at standard temperature and pressure. So we're going to plug these variables into this formula right here. My pressure is 1 atmosphere. My volume was 2.5 liters. Equals. N is what I'm looking for. That's the number of moles. R is 0.0821. And T was 273 Kelvin because it was standard temperature. So let's see what that comes out to be. See, I need to multiply these together. 0.0821 times 273. So I have over here, I multiply these together, which would be 2.5 equals N times 22.4133. So what I'm going to do is I'm going to get N by itself. I will divide both sides by 22.4133. Divide that by 22.4133. Sorry, there's a big mess there. 2.5 divided by that number. And that will give me number of moles, N. How many sig figs? I can have 2 sig figs. 0.11, those are my 2 sig figs. That 1 does not round it up, so 0.11 moles. That's my answer. All right, so we'll go on to number 7. Keep everything here. We've got some space that we can use down here. A 2-liter flask, that's my volume. 2-liter flask is filled with propane gas at 101.3 kilopascals and negative 15 degrees Celsius. It's supposed to be a degree sign. What is the mass in grams of the propane flask? Well, in order to calculate mass, I'm going to need to calculate moles. If I solve for moles, I can multiply by the molar mass of propane. Okay, so watch, we're going to do this. Okay, I know I need a P, a V, an N, which is what I'm going to look for, an R, and a T. So, see, 2 liters, that's my volume. Liters. And I have 101.3 kilopascals. Remember that in order to use 0.0821, I need my pressure to be in atmospheres. So I'm going to convert 101.3 kilopascals to atmospheres. Well, 101, okay, I'll do it. 101.3 kilopascals. I want atmospheres. I just go down kilopascals. Remember that 101.3 kilopascals is 1 atm. So 101.3 kPa is just 1 atmosphere. So Okay, and my temperature, negative 15 degrees C, so negative 15 plus 273 will give me the temperature in Kelvin. And 258 Kelvin. So I'm going to put these into my formula. My pressure is 1, my volume 2, equals number of moles times 0.0821 times 258. Okay, 2 equals N times what? 0.0821 times 258. 21.1818. 21.1818. So I divide both sides by 21.1818. 2 divided by that number gives me 0.0944 moles. N equals 0.0944 moles. Of what? Of C3H8. Remember, it's right there. So in order to turn moles into grams, 1 mole C3H8 is the molar mass of C3H8. So molar mass of C3H8. That means 3 carbons, so 12.011 is the molar mass of carbon times 3. And then 8 hydrogens, 1.008 times 8. So I add these two together. So plus that right there. And there we go. So the molar mass of C3H8 is 44.097. So I'm going to... Okay, sorry about that. I had to pause it for just a second. So we were doing some math here. We're going to multiply 0.0944 moles times the molar mass of C3H8. That's going to give us the molar mass of the gas in the container. 4.16 grams C3H8. Do you feel smart? You are.